Our research project is about a new method of mapping in an online and continuous fashion. This video provides supplementary visual explanations and results. We will first explain our method and then compare with other popular mapping techniques. Mapping begins with noisy online range sensor data, from which we sample surface points and normals. This allows us to build a continuous sign distance function representation of the map, modeled by a Gaussian process implicit surface, which we will denote as GPIS. We can also obtain distance gradient fields from GPIS, which can be very useful for robot planning. Now we will show a comparison of our method with other algorithms. To reiterate, our method represents a sign distance field continuously, as opposed to occupancy grid maps, which represent occupancy in a grid. Truncated sign distance function represents a sign distance function in a grid, while Hilbert map represents occupancy continuously. Now we will see the performance of each algorithm under a reduced data rate. This can happen when robots are moving fast and observing less of the environment, or when certain frames are occluded by a large amount and need to be thrown out, or by limited processing power and network bandwidth. Here's the range measurements sampled at 1 meter intervals to simulate the previously described conditions. In this case, occupancy grid maps suffer from disconnected cells, as not enough measurements have been made to trust a cell's occupancy. The truncated sign distance function has abrupt changes in its distance values. Hilbert map lacks accuracy and has poor edges. Our method, GPIS, shows consistent, robust distance predictions, as well as precise surface representation. We will now demonstrate our method on some real datasets. This animation shows the progression of our algorithm on the Intel Labs 2D LiDAR datasets. As you can see, we obtain an accurate map of a large and complex environments with online streaming updates. This method also works with 3D mapping and modeling. We observe an object with a depth camera with the RGB view shown in the right, and the point cloud shown in the middle. The gray mesh is the surface prediction from GPIS. We show the sign distance function at certain cross-sections of the object. As we observe more data, we can obtain a complete continuous 3D mesh of it. Thanks!